here and let you check your work. So 5.2, properties of parabolas, we were looking at 2 through 16 even, and number 19. When you look at number 2, we can use the negative b over 2a. B is the 4, make it a negative 4. A is 2, so 2 times 2 is 4. So it's negative 4 over 4 equals negative 1. So that is your axis of symmetry, right? X equals negative 1. You put negative 1 into this function. That means you put a negative 1 right here for the 2. A negative 1 for the x. And a negative 1 right there for that x. And when you do the math, you end up with negative 5. So we'll put that one right here. You could have it anywhere. So we had an axis of symmetry of x equals negative 1. This will be number 2. So we'd come over to negative 1. Hopefully right here at negative 1, you realize this is the center of your parabola. So when I look at your test, I will be looking to make sure you have your parabola located in the right place. That axis of symmetry helps you know where to locate it. And then negative 1, negative 5. So we'd go back 1, down 1, 2, 3, 4, 5. That is the vertex. Then I would need to know, if I look at this, the A, which is the 2, is positive, so it will open up. The negative 3 is what? Right here, what's that negative 3? I need y'all to play along right here, guys. Y-intercept. This is one of our properties that we're learning, that the C is the y-intercept. Everybody, since nobody said except for Malachi at the top of your paper, right up here, just remind yourself that the C is the y-intercept. That's a property of parabolas when it's in standard form. And why I care right here is that gives me another point. 1, 2, 3. There is another point on the parabola. The parabola is opening up this way. It would have a point that corresponds to it directly across. So that parabola would look, I don't know, something like that. Good with that? Okay. Let's put number 4 right here. Number 4, y equals x squared minus 4x plus 1. What is the axis of symmetry? Anybody know it? X equals, somebody help me out if you don't know it. I need your help. It is negative b over 2. What did you guys write on your paper? Where is your parabola's axis of symmetry? Just tell me. We're on number 4. Negative 2? That's close. What did you were on the right track. Negative 2 is on the right track. Huh? 2. It is 2. Because negative b would put a 4 on top. 2 times, what is a? A is an invisible what? 1. So 2 times 1 makes 2, which is 2. So we're going to come over here on number 4. Hopefully you have an axis of symmetry at 2. Two what is the vertex? The vertex, the x is 2. If you put 2 in there, what do we get? 2 squared is 4 minus 8 is negative 4 plus 1, negative 3. Very good. All right, a little bit of math there. So on your graph, hopefully on your graph, you go over 2, down 3. Hopefully you have a vertex at 2, negative 3. Oh, by the way, I forgot to mention right up here on number 2, it says for the minimum or the maximum, the minimum was y equals negative 5, or this point, negative 1, negative 5. Sorry, on number 2, The minimum is the lowest point. It doesn't have a maximum, it only has a minimum, right? Okay. This one, God, is there a shadow? I think I know the problem. Sorry. I feel like there's a big shadow there. Let's turn the light on. That helps a little bit. Okay. So I've got 2, -3 as my vertex. What is another easy point I can grab off of number 4? 1. 1 is the intercept. All right. Nice. So I come over here and I'll say this parabola would open up and touch the y-axis right there at 1. And there would be a point that corresponds to it directly across, right there. And so, drawing our parabola on your test. Make sure your parabolas have arrows on top. They have their vertex. They have at least one point coming in the right direction. And on this, we could say, on number 4, what is the minimum? -3. Y equals -3. Or if you had a test that asked for it, and if you gave the point to -3, that might be how you label the minimum. 6 has, I know that's kind of hard to look at. I was explaining this to a student yesterday. That's a cube. 6 has a quadratic term. And 6 has a C, which stands for what? What do you think? The constant. What do we not have on this quadratic expression? What? No linear term, which means if you think ax squared plus bx plus c, it does not have a b, which means we'll make the b 0. If the b is 0 on -b over 2a, -b over 2a, your numerator will be 0, right? And if the numerator is 0, the answer is 0. That tells me that the x is not moved right or left. Here is the answer to that. If you put in 0 for number 6, if you put in 0, guess what's left? The y-intercept. So the vertex is 0, -3. That means our minimum is y equals -3. That's all for number 6. And I like what you say. Let's put in 1. We need another point. We know the vertex is there. We know it's going to open up because the A was positive. Someone asked me yesterday, Mr. Bush, what if I wanted to put in 2 away from the vertex? We did the math. You were like way up here at 17. So 2, the parabola does continue to open up forever in both directions, but if I try to go 2 away from this axis of symmetry, if I went 2 away from my axis of symmetry, I'm off the page because it spreads up and out. So instead of trying to do 2, if you just stick 1 in for x, what we're saying is 5 times 1 squared minus 3. That becomes what? Y would equal 2. So when x is 1, y is 2. That's a nice, easy one right there. That's what I have when x is 1, y is 2. That's that point right there, 1, 2. And the parabola has one that corresponds to it. So there would be my parabola. All right, let's move to number 8. Number 8. 8. What is -b over 2a give us? One? Yes, because it's positive 10, -10 becomes positive 10 with -b over 5 times 2. 10 over 10 is 1. So hopefully number 8, your parabola is centered on the vertical line, x equals 1. What is the vertex? You put in 1. What do we get when we put in 1 for x? -9, I agree. How many people have checked? Raise your hand. I know people on the video won't be able to see this. How many of y'all have checked your work or confirmed your work or tried your work by looking at it on a calculator screen 2? It will be right if you put it in there correctly. So yes, your calculator screen should show you 1, 2, 3, 4, 5, 6, 7, 8, 9. It should show you that vertex. That means, hey, the minimum, this one opens up because the A is positive. That means y equals -9 is the minimum. And if I put in, we got a y-intercept right there, don't we? -4. 1, 2, 3, 4. 1 would correspond to it right there, wouldn't it? Do your parabolas look kind of like that? Notice anytime this A is a large number, the parabola is stretched, it's skinnier. You notice that pattern? Remember what we talked about yesterday? How you're able to go up 5 over 1 when that number is greater than 1. Does anybody remember that tip from yesterday? It works. Yeah, I remember we discussed it. All right. 10. Put that one right here, number 10. Somebody tell me where, we'll go a little bit quicker here. Somebody tell me on number 10, where's the vertex? Zero what? 0, 3. I agree. 10 doesn't have a B again, so it's not moved right or left. The y-intercept tells us it's just moved up. 0, 3. So when you put in 1, what do you get as an output? 4. So I need a point, so I just go 1 over. I get to 4. Point that corresponds to it's right there. This one would look like that. If you think, hey, we've discussed parent functions a little bit here, haven't we? You guys agree we've discussed parent functions? The parent function of quadratics is just y equals x squared. That is a parabola that's not been stretched, shrunk, shifted right or left, up or down. So that function number 10 is very close to the parent function. It only has a vertical shift up 3. We'll learn more about that. All right. Turn my page here. I'll put, this will be number 12 right here. 12, where is the axis of symmetry, somebody? -1. Does your parabola set back 1? If you look at that equation right there, that'd be -2 over 2 times what? 1. Thank you. Negative b over 2a gives you -2 over 2, which is -1. That is your axis of symmetry. Is this making sense? All right, so what's the vertex? The x is -1. What's the y? Anybody? 0. Yeah. So this one just shifts back, sits right there. It opens up. What's the y-intercept? 1. So right here's the vertex. It's going to touch the y-axis right there. There'd be 1 to correspond right there. There's your parabola. Good? Okay. Let's come down here. We're on number 14. Numero 14, por favor. Numero 14, por favor. 14. 14. Where is the axis of symmetry on 14? It'd be negative 12 over negative 3 times 2, right? Negative 12 over negative 3 times 2 makes a positive 2, because that's 12 over 6, right? So 2. Hopefully you have an axis of symmetry at 2. So when the x is 2, what's the y? What's the vertex? 4? 4. Everybody agree with 4? 2, 4, vertex. Does it open up or down? It's our first downward opening parabola. It's the first one with a negative 8. Aren't y'all happy you saw one parabola that opens down? I know y'all were getting really upset with this that you didn't get one that went down. But here we go. Well, what's an easy point to grab? What's an easy point off of this? Negative 8's an easy point to grab. So right here, 0. So 1, 2, 3, 4, 6, 7, 8. Right there. There'd be one to correspond to it right there. Woo! Parabola. Parabola. Y'all like it? Parabolas. I like parabolas. All right, 16. 16 is a really cool situation. It says, suppose you're tossing an apple up to a friend on a third-story balcony. After t seconds, the height of the apple in feet is given by this function. That function looks quadratic to me. That function looks like a standard form quadratic, where the height is a function of time. The height of the apple is based upon how long the apple's been in the air. Your friend catches the apple just as it reaches its highest point, miraculously. The chances of that happening. You ever do that game? We play this game where you try to throw a ball up and let it just get as close to the ceiling without touching it. And whoever gets the closest to the ceiling without touching it wins. Well, I'm not the only weird person in the room that's played that game. Okay. How long does the apple take to reach your friend? And at what height above the ground does your friend catch it? Please draw this picture with me. Here is a building. Friend is right up here somewhere. Hi, friend. There's the friend. Here you are. There goes the apple. There's the path of the apple. What does that look like? Parabola. We're going to label that path of apple. Friend catches it miraculously. Where? Highest point. The highest point of that parabola would be its vertex. Well, on the axis. Yes, on the axis. At the vertex. So if I know the vertex, I would know the x. What is the x in this situation? What's the input? What's the input? What's that letter right there? That's input relating to. What is it? Tell me, in real world, what are we talking about here? Time. So the right amount of time. So that vertex would be the exact amount of time it took for the apple to travel. All right, we're still talking about the vertex. What would the y-coordinate of the vertex be? So our vertex has time and what? Height. Very good. The right amount of height. At that vertex, at its highest point of the path of the apple, it would be the exact amount of time for the apple to reach the highest point. As time elapsed, the apple would then be coming down and the height would lower, wouldn't it? So if I could put this into my calculator and find the vertex, that might be the easiest way. Let's try it. Grab your calculator. Go to a graph. Menu. Graph entry. Function is fine. And type in said function. That's a negative 16. I'm just going to use x squared. I'm just using x squared, okay? X can be the same thing as t, okay? Hey, we're talking about standard form there. What do we got next? Plus 38.4 x plus 0.96. Oops, I didn't get it all in there. 0.96. There is that quadratic model, that quadratic function that would relate the path of the apple. Let's look at it. There it goes. There's the path of the apple. I don't really care about all of it. I'm gonna go menu. I'm gonna go 4 zoom. All I want is quadrant 1. That's where the business is happening. Oh, I can't even see the top of it now. Whoops. I'm gonna go menu. I'm gonna go 4. I'm gonna go window settings. On my Y max right now is 13. I'm gonna put it at 20. See if that works. It doesn't quite work. I'm gonna go menu. I'm gonna go zoom. Window settings. Y max. You said 25. That should get me there. 25. Enter. Okay, there I can see the apple flying through the air with that relationship. What do I care about? The vertex. Is there a way for this thing to show me vertex? I don't know. Let me hit menu. Let's analyze. 6. What can I hit off of there? Max? How'd you know my name is Max? Okay, 3. It always asks for the lower bound and then the upper bound. So I'm going to go below the vertex, hit enter, slide across. It said, hey, I found a maximum. Hit enter. There it is. Somebody, in real world terms, tell me what those two numbers mean before we... very good. 1.2 is time. 24 is hot. There is the amount of time it took. And miraculously, the friend caught it at 24. What are we talking about? Feet? Feet? Wow. I'm amazed by two things. All right, so the question is, how long did it take? 24 seconds. And it said at what height? Are we talking feet here? Oh yeah. 1.2 seconds and 24. We're talking feet here. Does it ever say? Oh yeah, the height of the apple in feet. Yeah, 24. I'm amazed by two things: that a third-story building is only 24 foot tall, and that they can do this. 1.2 seconds at 24 feet. There is a quadratic. There is a real life example where a quadratic model fits. All right, last one. 19. Is it similar? The path of a baseball after it's been hit is modeled by the function. Oh, looky here. Baseballs being hit could be modeled by a quadratic function where h is the height. Height is the output of d, the distance it travels. So the farther it travels, as it's traveling, it's going up. And how far is the baseball from the home plate when it reaches its maximum height? What is the maximum height and how far? Let's draw another picture. Now, guys, I got to be honest with you. I'm going to draw a picture, and I might be way off. Draw this picture with me. Here's home plate. We're going to call this home plate. I don't know if the baseball traveled like that. Actually, when I look at this number right here, it's negative, so I know it opens down. Baseballs normally travel this way. I've never seen a baseball travel in a parabola that opens up, right? But that negative right there told me that the baseball traveled up and then down, didn't it? And the fact that that number is really, really, really small, the absolute value of it's really, really, really small, told me that the person didn't pop up. Baseball people, you know what I'm talking about. What does it mean when you pop up? Go straight up. If this number right here would have been like -9, then that thing would have been a real steep parabola. Like it went up and the pitcher caught it, or the catcher caught it. But based upon that, I'm expecting this thing to maybe go to the outfield. I don't know. So it's a wider parabolic path. Have you already put it into your calculator and gotten the answer? What do we got? I've got to put it in. I'm going to go menu. How can I just change actions on the deal? Aha! Thank you. I just clicked on it. So now I'm going to go up here and change this function. I'm going to look at a new path. It's a negative point. Are you doing it with me? If you're not doing it with me, you're doing the wrong thing. All right, here we go. 0.0032. 0032. Just one right here, isn't it? Just 1x. And then a 3. All right, I can't wait to see the path. Here's the path. Whoa. I'm going to go zoom fit. That didn't help. Menu. 4. Zoom out. Let's try that. Keep zooming out. Keep zooming out. Keep zooming out. All right. Now I see it. There's the path. He did go to the outfield. Heck. Wonder how far he hit the thing. Now, what's interesting, anybody notice that it had a y-intercept? Anybody notice this y-intercept of 3 right here? It touched, that means before it traveled any distance, it was at 3. Somebody tell me why. Yeah. He hit the ball in air, didn't he? He didn't hit the ball off the ground like a golf ball. The ball was pitched to him. So the ball was 3 foot above the ground. Perfect distance. I mean, he was right there in the money. He swung the bat. It travels. It traveled way out there. Let's see. Is how far it traveled before it reached its highest point? 156 is highest. Oh, okay. Analyze. Maximum. Lower bound. Come across. Y'all see that? Y'all got that? 156 feet. It traveled 81 feet, 81.1 feet in the air. Is that the questions? What is the maximum height reached by the ball? 81 feet, right? 81.1 feet. How? Oh, was it rounding on mine? Okay. And then how far is the baseball from home plate? 156 feet. Oh, there it is, 156 feet. So, hey, what on a typical baseball field, who can tell me how far is a outfield fence from home plate? 350, right. So, and what did you say the ball hit the ground where? 312. So this ball was hit to the outfield somewhere-ish. It could have been hitting the gap. Outfielder might have caught it. I don't know. But it got 81 feet in the air. I would say that's not exactly a line drive. 81 feet's pretty high, isn't it? So he didn't hit it exactly on a line drive. This was more of a pop-up to the outfield. That's what I'm assuming. Very catchable, possibly. Very catchable ball. All right, good job. There's your answers. I love that we can apply to some real-world stuff.